welcome back. So now we are going to talk about a very famous data structure, that is tree. Okay, so in simple words, tree is a non-linear data structure which used to represent the hierarchical relationship. Okay, so what does it mean here, non-linear? Okay, we have to understand that. So non-linear means data is not stored in a straight line. You cannot store data like in a contiguous or something like that, like we have in array. Okay, so instead of this straight line, we store data in a branching structure. Okay, so what does it mean? Branching structure is like, suppose you are having one tree. Okay, there are multiple branches in that, right? So this is the root, this is the branch, this is itself part of the tree. So this can be treated as a separate tree, this can be treated as a separate tree, and this branch can be treated as a separate tree. So just like a real tree, we have a root. Okay, from root branch grows, and each branch can have more branches. So exactly the same concept we are going to use in the normally used in the this kind of data structure. Okay, so simple. If I tell you, a tree is a collection of node plus edge. Edge is nothing but it's a connecting line between the two nodes. We call it edge, correct? Each node is called root, and every node can have child node. Okay, so every node can have child nodes, so left child and right child we used to call it. And most important, there is no cycle, there cannot be a cycle in this. There is no cycle in the tree. Even though you create more node and more child, it's not going to create any cycle, right? If you see in the real life, in the file system, when you open your operating system in anywhere, so one folder is there, this folder can have another folder, and this folder can have one file, right? Or there is one folder and there is one file inside that. So this is called terminal. Means once you have the file, then you cannot create a node or create a folder inside this. It's a dead end. It's a end part in the given tree structure. Just like in the offices also, like in any organization, we have a we have a CEO, we have a manager, we have an employee. Okay, there are many things. So this is the hierarchical tree, right? In the family also we are having same thing, like our grandparents, right? Then parents, then child, correct? So this is also a hierarchy. So this is a family tree. So this real world data is hierarchical, not linear. So arrays that you have seen so far are flat data, while this tree are structured data, correct? So most of the use cases tree you might have seen in operating system, like file system, in auto suggestion. Suppose you are typing in somewhere, like any folder name you can take, like suppose X, Y, Z, then all the folder in this path is available, that also come in the suggestion, like X, Y, Z, A, X, Y, Z, B, this kind of folder will come. Apart from that, our database internal, if you see, database uses internally B tree. This is a special type of data structure where one node is there. One node can have multiple child node, not only two node. If it is two node, then binary. If it is three node, then ternary. If it is n node, then we call it n-ary. Okay, so these are all nodes. Okay, and I mean the data is their file. These are having the data file. Correct. So he ask you, if you observe this real world, most of the data is not linear. Think about your file system, think about your company structure, or even your family tree. Everything follow a hierarchy, and that's exactly where tree data structure comes into picture. Okay. So let's understand the terminology of the tree. Okay. So in tree terminology, we are having, I draw one picture, then I will tell you. This is 1, 2, 3, 4, 5, 6, 7. So starting node of the tree is called root. This is called childs, like left child, this is right child, correct? And this, the end node is called leaf. Is always the last part in the hierarchy. Okay. And this is called depth of the height, depth of the tree. So in this case, like 0, 1, 2, so depth of the tree is 2, right? So we call it somewhere, sometime it's a one layer, this is second layer, okay, this is the 0th layer, okay, like this. So this is the very basic terminology of the tree. So remember, a tree is a collection of nodes connected by the edges. Okay. So tree is a collection of nodes connected by edges, and it's form a hierarchical structure. So key point is that one node is called root node. Each node can have children, and there is no cycle. So formally, a tree is a collection of nodes connected by edges. But don't worry about the definition too much. Just remember, tree means hierarchy, right? And some real-time example that I told you: file system, organization structure, family tree, HTML, DOM, parser. Okay. So trees are not just the theoretical concept; they are used everywhere in your file system, in your company structure, even inside your browser as a DOM, right? So once you understand the tree, you start seeing them, everywhere. Okay, so we know the advantage of this, right? So it's represent the hierarchy naturally, first thing, and it's used in faster searching, especially in the optimized tree, and it's a very efficient data organization. Okay, so trees are one of the most powerful data structure. They help us to organize data efficiently, searching faster, solve complex problem easily, and trust me, tree based questions are the very common in the interviews. Okay, so in now in today's session, or in upcoming session with related to a tree, we are going to understand why trees are needed. We have seen this. Okay, we saw the limitation of linear structure and how trees solve those problems, right? So in the next lecture, we will go deeper into the tree structure, how we can represent the tree structure into the Java, so that we can solve our problems, right? So let's do that. So based on the tree, there are many patterns. And one more thing, like in array, what you do, you always start from the left or start from the right? And move. If you start from the left, then move towards the right. If you start from the right, then move towards the left, correct? So now stop thinking like that. Now for the especially tree, we have to start thinking like top to bottom, top, bottom, correct? Or reverse, bottom to top. So these only allowed because it is a non-linear data structure. Okay, so let's talk about the patterns which are based on the tree. One thing, our traversal pattern. So once you have got the tree, suppose if I ask you, can you find out all the nodes, or can you traverse across all the nodes and list out or print somewhere. So for this we are having multiple patterns. So one is the DFS, another one is the BFS. This is called depth first search, depth first search, and this is the breadth first search. Correct. So this is the, these two patterns are the foundation of all tree problems, most of the cases. Okay. Second pattern is height or diameter or depth. So like this is a depth, right? You know this. So many problems based on this, like find height, right? Or max depth, diameter. There are many problems which are based on this pattern. Okay. Now see the pattern 3. Pattern 3 is having the path based problem. So path based pattern, like, okay, can you give me route to leave path sum? Okay. Means you start from the root and take some path, and you have to find out that path where the sum of the nodes value are equal to some k, like 20 or 10. Okay, so you have to choose those paths. There are multiple paths, right, to reach this node. So you have to choose those paths where sum is equal to some given numbers. We call it route to leave path sum. Second is find out all the paths. It's a very simple one. Print all the paths. Then max path sum. Okay, so there are many variation of this problem, and we'll try to solve some of them. Okay, so these are the most asked pattern. Apart from that, one more pattern is there which is very famous, very important. That is BST. We call it binary search tree, BST. Correct. So this is a very special rule for this. It says left is always less than the root, means value wise, and root is always less than the right. Correct. So all the question based on this particular concept, like validate a given tree whether it's a BST or not. Okay, this kind of problem, or no, kth is smallest element you have to find. A lowest common ancestor, LCA, if you remember, lowest common ancestor, we call it LCA problem. Okay, so there are many things which are variation are having for this pattern. This is the pattern 4. Now coming to pattern 5. It's a very important and big topic. We are going to take time in this. Okay, so keep patience and just learn. This is the based on the subtree or comparison. So what does it mean? Subtree or comparison means, like, two trees could be given and ask you, can you see if both trees are same or not? So same tree or not. This kind of problem we can see. Okay, symmetric tree is a very classic problem. Normally people used to ask this. Okay, so here we are going to see one more concept, that is recursion, because we have to do the same certain operation for each node. Okay, so we'll see this is a separate itself, a very big topic, but we'll try to cope up with that. Okay, so most important from the point of view that you should know, at least we are having traversal, that I'm going to talk about this. Second, dividing the problem into two types, like sub problems, you can say sub problems or subtree. So these are three categories, you can say it. We are going to solve our problems doing something based on this, some operation like that. Okay, then later, combine the result. So this, these are core logic. So almost every tree problem, somewhere revolve around these points only. Okay. So in this particular section, we are not going to just learn tree. We will master the tree patterns like traversal, height calculation, path problem, binary search tree logic, and many more. So by end of this lecture, you'll be able to break down any tree problem with very confidence. You can give the answer. Okay. So what I'm going to do now, in the next video, we are going to represent the tree structure with the Java. Then we start taking the small and medium problems to solve that, or patterns to solve that. Okay. So let's see in the next one.